Welcome to Deep Dive Talk. Today we're plunging into the really fascinating world of dopamine. It's such a crucial neuromodulator buzzing away in your brain.
Absolutely. And our mission today for this deep dive is to unpack what dopamine actually is, explore how it works, the kind of intricate ways it operates.
Yeah, get into the nitty-gritty.
Exactly. And uncover some of the, well, surprising influences it has on your motivation, your focus, your overall sense of well-being, really. We'll be looking at the science, the research, expert insights, all that good stuff.
Okay, great. Let's start right at the beginning then. What is dopamine? It sounds super important.
It really is. So dopamine, or DA, as it's often shortened, it's a neuromodulatory molecule. Technically, it's part of the catecholamine and phenethylamine families.
Okay, big words. But what does that mean in practice?
Well, what's really striking is that it makes up about 80% of all the catecholamines in your brain, a huge chunk.
80%. Wow. Okay, so where does our brain even get it from? Do we just make it?
We do make it, yeah. It's synthesized from something called L-DOPA, and L-DOPA itself comes from an amino acid, tyrosine.
Tyrosine. That sounds familiar. Is that in food?
Yes, exactly. You find it in protein-rich foods. Think turkey, beef, eggs, dairy, soy, legumes. Lots of common stuff.
Ah, okay. So eating protein helps make dopamine.
It provides the building blocks, yeah.
Mhm.
And once your brain makes the dopamine, it acts as a neurotransmitter, basically a chemical messenger, relaying signals between nerve cells, your neurons, in different parts of the brain.
So it's like the brain's internal messaging system, sending little notes around.
That's a great way to think about it, actually. And one of its most famous jobs is in motivation, specifically the motivational part of reward-seeking behavior.
Reward seeking, like wanting something good.
Precisely. When you anticipate most kinds of rewards could be basic, like food, or something complex, like achieving a goal, your dopamine levels tend to increase. It's that get up and go signal, that feeling of, ooh, something good might happen.
Right. I get that. You feel a bit buzzed just thinking about something you want. So how does it actually send these messages? What's the mechanism down at the cell level?
Okay, so dopamine works by binding to and activating specific dopamine receptors. These receptors are on the surface of cells.
Like little docking stations.
Exactly like docking stations.
Yeah.
In humans, we know of 5 main types or subtypes. They're just called D1, D2, D3, D4, and D5.
D1 through D5, easy enough.
And all of these are a type of receptor called G protein-coupled receptors, which basically means when dopamine docks, it triggers a chain reaction, a cascade of events inside that cell.
Okay, G protein coupled. Do all 5 D receptors do the same thing when dopamine hits them?
Not quite. They're sort of grouped into 2 families. You've got the D1-like family, that's D1 and D5. These can be excitatory or inhibitory.
Meaning they can either like step on the gas or the brake for the neuron.
Yeah, that's a good analogy. Excitatory makes the neuron more likely to fire off its own signal. Inhibitory makes it less likely. Then you have the D2-like family, D2, D3, and D4. These ones are usually inhibitory.
Mostly brakes in for the D2 family.
Generally, yes. So the overall effect dopamine has on any given neuron really depends on which specific types of these D receptors are present on that cell surface. It's not just one simple message.
Huh, interesting. So it's complex signaling. What happens to the dopamine afterwards? After it's delivered its message, does it just float away?
Good question. No, it gets cleared out of the synapse. That's the little gap between the nerve cells. There are 2 main ways. It can be sucked back up into the neuron that released it. That's called reuptake, like recycling it.
Okay, reuse it later.
Right. Or it can be broken down by specific enzymes. The main ones are called MAO monoamine oxidase and COMT catecholomethyltransferase. They basically deactivate it.
Got it. Reuptake or breakdown. Okay, so that's the basic machinery. Now, let's get into something I think lots of us grapple with. Motivation and effort. I always sort of thought dopamine was the pleasure chemical, but you said it's more about wanting. What's the difference?
Yeah, that's a really, really important distinction that's come out of research more recently. Initially, yeah, the thinking was heavily focused on pleasure, the liking of a reward, but now the science really highlights dopamine's critical role in the wanting, the motivation, the drive, the urge to actually go after goals you desire.
So liking is enjoying the ice cream, but wanting is what gets you off the sofa to go to the freezer in the first place.
Exactly. That's a perfect way to put it. And studies back this up. If you reduce dopamine levels, say in lab animals, it doesn't necessarily seem to stop them from enjoying a reward once they get it. They still like it,
Okay.
but it dramatically reduces the amount of effort they're willing to put in to obtain that reward.
Ah, okay. You mentioned a rat study earlier. Tell me about that.
Right. So in this classic kind of study, rats with depleted dopamine, they weren't less interested in a really pacey bit of food compared to plain chow. They still preferred it if it was right there. But if they had to, say, climb over a little barrier or press a lever many times to get that tastier food, they just wouldn't bother. They'd settle for the easy, less appealing option right next to them. They became, for lack of a better word, lazy about pursuing the better reward.
Wow. So the desire was there, but the get up and go wasn't.
Precisely. The motivation to exert effort was gone. And this might sound familiar, right? Ever had that feeling where you know you should do something, maybe something you'd even enjoy once you start, but you just can't summon the energy to begin?
Oh, absolutely. All the time. That feeling of inertia. So dopamine helps us push through that, overcome the effort barrier.
That seems to be a key function. It helps us overcome the perceived cost of effort. It fuels the motivation needed to engage in actions that require work, actions that aren't immediately gratifying. It's the neurochemical kickstart for effortful behavior.
That makes so much sense.
Yeah.
Okay, now what about these dopamine peaks and troughs? You get a big rush from something fun, but then what?
Right. So when you engage in something really pleasurable, you often get a significant release of dopamine that's the peak. A big surge.
Is good.
Absolutely. But what's interesting, and maybe less intuitive, is that this peak is often followed by a period where your baseline level of dopamine actually drops. It goes below where it started.
Oh, really? So it's not just back to normal, it's lower than normal.
For a period, yes. It's a dip, a trough. And this peak and trough dynamic might explain why, after some really intense pleasure or excitement, other things can feel a bit flat, or you might feel less motivated for a while.
Like you've used up your juice, squeeze the lemon dry for a bit.
That's a good analogy. Your system's baseline has temporarily shifted downwards. And this also ties into how we think about rewards, rewarding yourself after completing a task.
Yeah, I thought that was supposed to be good motivation. Finish the report, get a cookie.
It can feel good, sure, but relying only on that external reward afterwards might not be the best way to build motivation for the task itself. The dopamine peak from the cookie isn't necessarily linked to the effort of writing the report in your brain.
Ah, I see. You're training your brain to want the cookie, not necessarily to find satisfaction in the work.
Exactly. It keeps the focus on the external prize, rather than potentially helping you learn to associate the effort, the process, the challenge itself with a sense of reward or satisfaction.
That's a really subtle but important point. Okay, this is fascinating. Let's shift to some of those surprising triggers you mentioned. Cold water exposure. Seriously, like a cold shower.
Even more intense, actually. Studies looked at immersion in cold water up to the neck, and what they found was pretty remarkable. A significant and sustained increase in dopamine levels,
How significant are we talking?
up to 250% above baseline levels.
Whoa, 250%. That's huge. It's comparable to some drugs, isn't it?
It is, in terms of the peak level, but crucially, unlike many drugs, this increase was sustained for quite a while, and importantly, it wasn't followed by that sharp crash, that deep trough we just talked about.
Wow. Okay, why? What's the cold water doing?
The exact mechanisms are still being fully mapped out, but a leading idea is that the intense shock of the cold water is a strong activator of the sympathetic nervous system, your fight or flight response.
Right. Adrenaline.
And norepinephrine, yeah. And norepinephrine release, in turn, seems to stimulate dopamine production and release in key brain areas linked to mood, focus, and vigilance.
So the shock triggers a cascade that boosts dopamine, and it lasts.
It seems to be more sustained, yes, which could explain why people often report feeling really good, focused, and alert for hours after cold exposure. But there's a caveat.
Oh, okay, what's that?
Novelty. Once you get used to the cold water, once you adapt, the effect might diminish. The shock isn't as shocking anymore, so the dopamine response might not be as pronounced.
Makes sense. Your body adapts. Okay, what about protein? You mentioned tyrosine earlier. How direct is that link?
It's pretty direct. Protein provides the amino acids, and tyrosine is one of them. Tyrosine is the essential precursor molecule. Your body takes tyrosine, converts it into L-dopa, and then L-dopa gets converted into dopamine.
So no tyrosine, no dopamine. Or less, anyway.
Essentially, yes. If you don't have enough tyrosine coming in from your diet from those foods like meat, eggs, dairy, soy, legumes, your body just doesn't have the raw materials it needs to synthesize dopamine effectively. So adequate protein intake is fundamentally important.
It's literally the fuel for the dopamine factory.
That's a great way to put it. Fuel for the factory.
Okay, and novelty. You said the brain likes new things.
It does. Your hippocampus, which is heavily involved in learning and memory, seems to place a high value on novelty. When something is new or unexpected, it tends to grab attention and can trigger dopamine release.
So shaking things up can boost motivation.
It seems so. If you have a task that feels boring or challenging, introducing some new element, changing the environment where you do it, trying a slightly different approach, that novelty can sometimes spark a bit more dopamine and make you feel more engaged.
Keep it fresh. I like that. And the last surprising one was social connection. How does hanging out with friends link to dopamine?
It's a really powerful link. Close, positive social interactions, the kind that make you feel connected, supported, understood these experiences, are known to trigger the release of oxytocin.
The love hormone or bonding hormone. Yeah.
Exactly. And it turns out that oxytocin release also stimulates dopamine release in the brain's reward pathways. So feeling socially connected is intrinsically rewarding on a neurochemical level.
Wow, so our brains are literally wired to find connection rewarding through dopamine.
It really underscores how fundamental social bonds are for our well-being and, yes, our motivation, too. It reinforces the behaviors that lead to connection.
That's amazing. Okay, so dopamine does all this great stuff, motivation, reward, anticipation, focus, but you called it a double-edged sword. What's the catch? Where's the downside?
Well, the potential problem arises from how easily accessible some really high dopamine-releasing activities are in the modern world, often requiring very little effort.
Like what?
Think about things like really intense internet pornography, highly palatable processed foods packed with sugar and fat, maybe even some aspects of social media or video games designed to be hyper-engaging. These things can cause massive, rapid spikes in dopamine.
Okay. And the problem with big, easy spikes is?
The issue is that your brain can adapt to these unnaturally high levels. Over time, it can raise your arousal threshold. Basically, your baseline for what feels rewarding or stimulating gets pushed higher and higher.
So everyday stuff starts to feel boring.
Exactly. Normal, healthy pleasures, a good conversation, reading a book, enjoying a walk in nature, they might not deliver that same intense hit, so they start to feel less appealing, less rewarding. It can lead you into a cycle of constantly seeking out stronger and stronger stimuli just to feel, well, normal or even just okay.
Like building up a tolerance.
Very much like tolerance, yeah. And it's not just about feeling bored. With substances that cause really sustained high levels of dopamine release, like amphetamines or cocaine, there's evidence they can actually cause long-term harm to the dopamine pathways themselves. They can damage the neurons.
Yikes. Okay, that's definitely the sharp edge of the sword. So given all this, how can we manage our dopamine in a healthy way? Avoid the pitfalls, keep things balanced. What strategies actually work?
There are definitely strategies. One really powerful one is to consciously shift focus towards effort-based rewards. This ties into the idea of a growth mindset.
Growth mindset.
Meaning, learning to find the reward not just in the final outcome, the prize at the end, but in the process itself. Finding satisfaction in the challenge, in the learning, in the overcoming of difficulty.
So learning to enjoy the climb, like you said earlier.
Exactly. If you can start associating the feeling of effort and progress with dopamine release, you build a much more sustainable and resilient form of motivation. It's intrinsic, coming from within, not just relying on external treats.
Okay, focus on the effort. What else?
Be mindful of something we could call dopamine layering. This is really relevant today.
Dopamine layering. What's that?
It's combining multiple sources of dopamine release at the same time, especially during an activity you want to find inherently rewarding long-term.
Like scrolling social media while watching a movie. Or listening to music while trying to study.
Precisely. Or checking your phone constantly while you're having dinner with someone. Each notification, each quick hit from the secondary activity layers on extra dopamine. The risk is that it can actually reduce the pleasure and satisfaction you get from the main activity.
Because your brain gets confused about where the reward is coming from.
Sort of, yeah. Or it just gets habituated to that higher combined level of stimulation, making the primary activity feel less engaging on its own later. So the advice is often, try to unitask. Immerse yourself in one thing you want to enjoy. Put the phone away during meals or conversations.
That makes a lot of sense. Reduce the noise. What about caffeine? Good or bad for dopamine?
Caffeine is interesting. In moderation, it seems it can actually be beneficial. It doesn't directly spike dopamine release hugely, but it can increase the number and sensitivity, the efficacy of your D2 and D3 dopamine receptors.
So it makes your existing dopamine work better.
Potentially, yes. It might make you more sensitive to the dopamine that's naturally released. And there's some interesting research on yerba mate specifically, suggesting it might even have some neuroprotective effects for dopamine neurons.
Yerba mate. Okay.
But again, moderation is key. And be careful combining caffeine with other things that strongly affect dopamine, like MDMA, for instance, that can be a dangerous interaction.
Right, moderation and being mindful of interactions.
Hmm.
Got it. Now, what about dopamine fasting? I hear that term thrown around. Is that a real thing?
It's a bit of a misnomer, really. You can't and wouldn't want to actually fast from dopamine. It's essential for normal function, even just for movement.
Okay, so what do people mean when they say that?
What they generally mean is more like intentionally reducing exposure to overstimulating activities, identifying those things that give you huge, easy dopamine spikes. Maybe it's compulsive phone use, binge watching, certain foods, and consciously choosing to step back from them for a period.
And replacing them with...
Replacing them with less stimulating, perhaps more mindful activities, things like spending time in nature, reading a physical book, meditation, exercise, engaging in a hobby that requires focus but isn't intensely rewarding every second.
So the goal isn't zero dopamine, it's resetting your sensitivity, dialing back the intensity so you can appreciate simpler things again.
Exactly. It's about trying to rebalance your brain's reward circuitry, recalibrate your baseline, so that everyday life and effortful activities feel more naturally rewarding again.
That makes more sense than just fasting. Okay, any other strategies?
Absolutely. Don't forget the fundamentals. They play a huge role. Prioritize good sleep. Sleep is critical for brain health and neurotransmitter regulation, including dopamine.
Sleep, always important.
Yep. And getting natural sunlight exposure, especially in the morning. Sunlight helps regulate your circadian rhythm and cortisol levels. Cortisol, the stress hormone, has complex interactions with dopamine. Managing cortisol often helps balance dopamine.
Morning light, okay.
And finally, back to basics. Good nutrition. We talked about protein for tyrosine, but overall balanced nutrition supports all your brain's functions.
So sleep, sunlight, nutrition. The foundations of health really do underpin this complex neurochemistry.
They really, really do. You can try all the fancy hacks, but if the foundations aren't there, you're fighting an uphill battle. Ultimately, understanding how dopamine works isn't about biohacking your way to constant highs, it's about empowerment. Empowerment? How so? It empowers you to make more conscious choices. Choices about the activities you engage in, the habits you cultivate. Knowing how dopamine influences your motivation and well-being allows you to think differently about why you do what you do.
Instead of just chasing the next quick hit.
Exactly. Instead of chasing those fleeting, maybe ultimately unsatisfying dopamine highs, you can start thinking about how to cultivate a more balanced, sustainable sense of drive, satisfaction, and meaning in your life, focusing more on that effort-reward connection we talked about.
That's a really powerful shift in perspective. Moving from seeking passive pleasure to actively building a motivated, engaged life. It's less about finding dopamine and more about structuring your life so dopamine supports your goals.
Beautifully put. That's exactly it.
So thinking about that, what's maybe one small, actionable thing listeners could consider today? A way to start applying this understanding.
Maybe just take a moment to notice. Notice one activity you do that gives you that quick, easy dopamine rush, but maybe doesn't feel deeply satisfying afterwards. And then, maybe just once, consciously choose to swap it for something else. Something that requires a little more effort, but might connect you more to that feeling of accomplishment or genuine engagement. Even a tiny shift can start rewiring those pathways.
A small swap, a conscious choice. I like that. Well, that was certainly a deep dive into the truly fascinating world of dopamine. Hopefully this has shed some light on how this vital neurochemical is working away behind the scenes in your daily life.
Yeah, we hope it's given you some valuable insights, maybe some food for thought. We encourage you to reflect on this, maybe even explore some of those strategies for keeping your own dopamine system healthy and balanced. It's such a complex area. We're always learning more.
Absolutely. And if you found this deep dive interesting, we'd genuinely love to hear your thoughts or any questions that came up for you. There's always more to explore.